The first case is if x of n is real valued. That is, when x of n is real valued, then x of n minus k is equivalent to x of minus k, that is x of star of k. The second case is when x of n is real and even, that is x of n. So when this happens, x of n is equivalent to x of capital N minus n. This gives x of k is equal to real part of x of k. Here the imaginary part is 0. The third case is x of n is real and odd. That is x of n is equal to minus x of n minus n. Then DFT is equivalent to x of k is equal to minus j summation n is equal to 0 to capital N minus 1 x of real part of n into sine 2 pi k n by capital N. And finally, when x of n is imaginary, then we finally get, as real part will be 0, x of r of k is equal to summation n is equal to 0 to capital N minus 1 x1 of n sine 2 pi k n by capital N. And similarly, xi of k is equal to summation n is equal to 0 to capital N minus 1 xi of n cos 2 pi k n by capital N. Now we are going to solve a sum based on symmetry property. The question is, the first 5 points of 8-point DFT of real valued sequence are 0.25, 0.1.25 minus j 0.3018, 0, 0.125 minus j 0.0518 and 0. And we have to determine the remaining 3 points. Now we know that first 5 points are given, that is x of 0, x of 1, x of 2, x of 3 and finally x of 4. So now we know that this sequence is real valued sequence. According to the property of symmetry, we have x star of k is equal to x of n minus k. That is equivalent to x of k is equal to x star of n minus k. This is a 8-point DFT. So n is equal to 8. X of k is equal to x star of 8 minus k. Now we want the remaining 3 samples, that are x of 5, x of 6 and x of 7. We will find out every sample one by one. First, x of 5 is given as x of star 8 minus 5, that is x of star 3. Now we know that x of 3 is equal to 0.125 minus j 0.0518. Now we have to remove the complex conjugate. So it gives x star of 3 is equivalent to 0.125 plus j 0.518. Thus, x of 5 is equal to this. Similarly, for x of 6, we need to put is equal to x of star 8 minus 6, that is x of star 2. Now x of 2 is 0. So again x of star of 2 will also be 0. So x of 6 is equal to 0. Similarly, at last, x of 7 is equivalent to x star of 8 minus 7, that is x star of 1. X of 1 is given by 0.125 minus j 0.3018. So x star of 1 will be equivalent to x of 7, that is complex conjugate of x of 1. So this is the final answer. Finally, we found out the remaining 3 points. Thank you.